All right. So the first definite integral, this is very straightforward. You're really just doing two things. You're finding the antiderivative, and then you're plugging the numbers in. Top number goes first. You subtract what you get when you plug in the bottom number. So first, I'm going to find my antiderivative. I add 1 to the power. You know, if you need to do it on the side, do it on the side. Add 1 to the power. So then the power becomes 3. Divide by the new power that you got. So that's going to be x to the third. Now I have to add 1 to that power. There isn't one. So when you see something, when you see just a constant, you have to just throw an x onto it. I mean, right? If you add 1 to 0, you get 1. And then when you divide by 1, you get the same number that was there. So no big deal. Now, no plus c. I'm going to put a big ass line. So antiderivative evaluated at 3 and negative 1. That's what this line represents. It means that I'm going to evaluate this at those numbers. So the top number goes first. You have to do this very precisely. Everywhere you see x, you put the number on the top. There are two. You don't put a 3 here and a negative 1 here. It doesn't work that way. I have to compute this thing for 3, for x is 3, and then I have to compute it for x is negative 1. So first I plug in the 3. Then you got to plug in negative 1. Be very, very careful here. I mean, even though you guys are in calculus, you can make mistakes with this, with your signs and with your powers very, very easily. This is 27. This is 6. Negative 1 to the third, be careful. Negative 1 to the third is negative 1. And then positive 2 times negative 1 is negative 2. Now put it all together. This is 33. Take away. Now, this is negative 3. I am not skipping nothing. I'm writing it all out very, very carefully. This is 33. A negative, take away a negative is a positive. So the answer here is 36. What the hell is this supposed to be? If you were to sketch this graph of this thing, which is a parabola, and you were to try to find the area of it between negative 1 and 3, this is what it would be. And you're like, 36 what? I mean, if you did your x-axis in inches, then this would be like 36 inches squared or something like that. All right, so that number represents the area under the curve, but who cares? You just have to get the number. All right, the second problem. I'm doing another definite integral. I'm going to find the antiderivative, and I'm going to plug these numbers in. So now I have a trig function this time. Pi over 2 is 90 degrees. I mean, I'll write this in the end. Pi over 6, remember, pi is 180. So 180 over 6 would be 30 degrees. So basically, I'm going to plug in 90 and 30 degrees at the end of this. So first, you integrate. You find the antiderivative. Now be careful. When you take the derivative of cosine, you get negative sign. But I'm not taking a derivative here. I'm doing an antiderivative. So here, I don't switch my sign. I want to know who had the derivative of cosine. So if I take the derivative of sine, the derivative of sine is cosine. So I don't switch signs here. Now I want to evaluate at 90 and 30, right? Antiderivative, and then evaluate it. Put this big ass line with the numbers there. Now I'm going to plug them in. Top one goes first. So you put pi over 2, which is 90 degrees. Take away 2, if you want to be more precise. Sine pi over 6. And again, pi over 6 is 30 degrees. So this is 90 degrees. This is 30 degrees. Now, I know the sine of 90 is 1. So where that is, you put a 1, right? Now, sine of 30, you may forget. This is why I gave you on Blackboard. You have your trig chart with all the values. The sine of 30 degrees is 1/2, right? Sine of 45 is radical 2 over 2. Sine of 60 is radical 3 over 2. These are numbers you've seen before, even if you've forgotten them. But that's why I gave you the cheat sheet. And you are allowed to use it. That's why I gave it to you. 2 times 1/2, well, half of 2 is 1. 2 minus 1 is 1. Wow, so difficult. I mean, the hardest part of this is here. Just either remembering what the values are or having to open up the sheet and look at them. All right, so again, antiderivative, evaluated at those two numbers, plug them in, figure out the values, subtract them, and then it's over. Okay, the next one, I want to find the definite integral from 8 to 1, or 1 to 8, however you want to read it, of 1 over the cube root of x, that's a 3, plus x dx. So the first thing I'm going to do is rewrite it. I'm going to put 1 to 8. I'm going to leave that there. I'm going to switch this to 1 over x to the 1/3, right? This is the cube root. So it's the 1/3 power. I'm not going to mess with that. I'm not going to mess with that. Now I have to do one more rewrite. So I want to do this first. This has to go up. I cannot, I couldn't find the derivative when it was like this. When I used to take derivatives with the power rule, I had to make sure that it was x to the p. So when I do an antiderivative, it's the same thing. I'm going to move this upstairs and make it x to the negative 1/3. So that's my big move. That's the power move. Now I can find the antiderivative of it. And again, I'm going to do it on the side. I'm going to be very precise with this. I have negative 1/3. I want to add 1 to this power. Well, turn the 1 into 3 over 3. So my power now is going to be, right, 3 minus 1 is 2. The bottom stays the same. Don't forget to divide by the new power. So remember what I taught you. When the power is a fraction, flip it over and put it in the front. Wow, that was hard. Okay, so the antiderivative of x to the negative 1/3 is 3 over 2, x to the 2/3. Now I have to find the antiderivative of x. Not hard. It's x to the 1. Add 1 to the power, which makes it x squared. And then if you want, you could flip that power over and put it in the front. That works if it's a whole number too. And then evaluate it at 1 to 8. Put that big ass line. This is what you do. You find the antiderivative and you evaluate it at 8 and 1. Now, the question is, how the hell are you going to plug 8 into that? Now, remember what the 3 means. The 3 means cube root. So you're going to see in my next step, I'm going to write it this way. You're going to take the cube root, and then you're going to square that, right? The 2 on the top is a regular power. The 3 on the bottom is a root. So when I have an 8 in there, the first thing I'm going to do is take the cube root. You do not want to square this. Why would you make the number bigger, especially if you don't have a calculator? So you want to do the cube root of 8 first and then square it. So that's how I'm going to evaluate this. So I'm going to have 3 over 2. I'm going to take the cube root of 8 and square that. Then I'm going to do, I'm not going to have enough room to do this. I got to write it again. I'm going to start all the way over here. There's no way I'm going to fit it there. So let's try this again. 3 over 2, cube root 8, because I'm writing it really big. Make sure you all see it all right. Plus 1/2 8 squared, right? 8 has to go here and here. First, the top number goes everywhere you see x, and then put big ass parentheses here. Take away, same thing. Now the 1 is going to go here, and the 1 is going to go there. So you do 3 over 2. Now, 1, this time it doesn't matter. No matter what power you raise 1 to, you get 1. You do 1 to the 2/3, it's 1. You do 1 to the 55 over 7, 1. It doesn't matter what power of 1, you get 1. And then you're going to do 1/2 times 1 squared, which is also 1. So back to here. I plugged in 8. The cube root of 8 is 2. So through the magic of erasing, cube root of 8 is 2. 2 squared is 4. So put a 4 there. Plus, now 8 squared is 64. I'm going to end up taking half of that. I don't want to skip anything. I'm going to write it all out. All right. So I did the cube root of 8 and got 2. And then 2 squared is 4. I did 8 squared to get 64. Take away 1 to the 2/3 is 1. And 3 over 2 times 1 is 3 over 2. 1 squared is 1. And you have to do 1/2 times that. Ooh, this is going to work out pretty nice. Now, divide 4 by 2, and you get 2. 3 times 2 is 6. Plus half of 64. Half of 64 is 32. minus, check this out, 3/2 plus 1/2. This is a gift. That's 4/2. Yay! 4/2 is 2. Oh, man, son of a gun, the fraction disappeared. Yay! That was very lucky. That wasn't by design either. That just happened. 38, take away 2, right? 38, take away 2. 36 again. Wasn't our first answer 36? I love it. What are the odds? Well, you get 36. There you go. You have to be this is a very, very tricky question because you get a fraction. So I wanted to make sure I did one where you had a fractional exponent. But again, not a big deal. You just do the cube root first, then you square it. And notice, I made sure you got numbers that this comes out nice. I mean, if I had put a 7 here and you had to do the cube root of 7, they just screwed. I made sure I gave you a number that has a nice cube root. And the numbers aren't too big. They're not too monstrous. So everything worked out pretty good. You just have to be very careful when you have powers that are fractions.